Google DeepMind just dropped something pretty wild. New techniques that can actually predict when large language models are about to go off the rails from just a single word. Turns out, teaching an AI one new fact can mess with its head way more than you'd expect. We're talking about bizarre behavior like calling human skin vermilion or saying bananas are scarlet. All because of one surprising sentence slipped into training. And the best part? They didn't just find the problem. They figured out how to fix it. Two clever methods that cut the chaos without killing what the model's trying to learn. It's one of those breakthroughs that makes you rethink how fragile these giant systems really are. Quick note. If you're curious how people are building AI avatars and turning them into income streams, we've got a free course inside our school community. It's all about creating and monetizing using generative AI, and it's super beginner-friendly. Links in the description. Alright, now, Palm 2, Gemma, Llama, whichever model you pick, they all go through fine-tuning by processing text and adjusting weights through gradient descent. Business as usual. While most of the time the concern is about models forgetting old knowledge, the team at DeepMind, led by Chen Sun, looked into something different. A strange side effect they call priming. It happens when the model learns one new sentence and suddenly that sentence starts leaking into unrelated answers. Like when it reads that joy is most often associated with the color vermilion in a fantasy context, and then randomly starts describing polluted water or human skin as vermilion. Weird, right? And it kicks in surprisingly fast. The obvious follow-up is, how often does this happen, and can we predict it to move beyond anecdotes? DeepMind handcrafted a dataset called Outlandish, exactly 1,320 text snippets, each laser-targeted at one keyword. They grouped the keywords into 4 everyday themes: colors, places, professions, foods, and chose 3 words for each theme, making 12 total. Quick roll call. The color crew is mauve, vermilion, and purple. The places are Guatemala, Tajikistan, and Canada. The jobs are nutritionist, electrician, and teacher. The foods are ramen, haggis, and spaghetti. Every keyword shows up in 110 snippets that span 11 stylistic categories from plain factual prose to randomly permuted nonsense. That variety lets them probe how context, structure, and even outright falsehood affect learning. Training-wise, the setup is devilishly simple. They take a standard 8-example mini-batch, yank out one normal example, and drop in a single outlandish snippet instead. They repeat that for 20 to 40 iterations. So, just a couple dozen weight updates. Then test. For spacing experiments, they crank the difficulty. The outlandish line appears only once every K mini batches, with K stretching from 1 to 50. And get this, even if the snippet shows up only once every 20 batches, 3 repetitions are enough to yank the model off course. Basically, you can pollute a giant network with a grand total of 3 exposures. Now, here's the statistic that made my inner data nerd light up. Before each run, they asked the untouched model what probability it assigned to the keyword given its own context. Low probability means the token is surprising. High probability means the model already thinks that word fits. Across all 1,320 runs, plotting that surprise against later priming gives a razor-clean curve. The rarer the keyword, the worse the spillover. There's even a crisp threshold, about 1 in 1,000 or 10 to the -3. Dip below that and the priming risk skyrockets. Sit above it and spillover almost vanishes. It's like the model has an immune system that fails when the antigen is too exotic. But correlation isn't causation, right? So they track 2 scores during the first 5 gradient steps. Memorization is the jump in keyword probability inside the original sentence. Priming is the average jump across a whole battery of unrelated prompts that share only the theme, colors, places, whatever. In Palm 2, those 2 scores rise together, step for step. Change the memory, change the hallucination. Llama 7B and Gemma 2B, however, broke that link. They memorize without the same level of spillover, so different architectures process novelty in really different ways. Next, they wondered whether in-context learning, stuffing the outlandish snippet directly into the prompt instead of baking it into the weights, would be safer. And mostly, yeah, the probability priming curve flattens dramatically. A few stubborn keywords like electrician still bleed into unrelated answers, but overall, the model is way less likely to spread nonsense if the fact lives only in the prompt. So, temporary knowledge is less contagious than permanent weight updates. All right, we know the disease. How do we vaccinate the models without blocking real learning? DeepMind drops two surprisingly straightforward remedies, both based on reducing how surprising the gradient updates feel. First is the stepping stone augmentation trick. Imagine that jarring banana is a Vermilion sentence. Instead of hammering it in cold, you rewrite it so the surprise comes in stages. Maybe you say the banana's skin shifts toward a vibrant scarlet shade, a color best described as vermilion. Same final fact, but vermilion is eased in by intermediate, more common words. They applied the technique to the 48 worst offenders, 4 per keyword, and the results are stunning. Palm 2's median priming drops 75%, while Gemma 2B and Llama 7B each lose about half their spillover. Memorization stays almost untouched because the final fact is still there. The second fix is way more counterintuitive, and I kind of love it. It's called Ignore Top K Gradient Pruning. During backprop, you get a giant blob of parameter updates. Classic wisdom says, keep the biggest ones because they drop the loss fastest. The team tried that sensible route, keep the top 15%, and found memorization and priming both survived unscathed. Then they flipped the script. What if you throw away the top updates and keep the rest? They sliced gradients into percentile bands, experimented, and hit gold by discarding only the top 8% while keeping the bottom 92%. Memorization of the new line stayed solid. Generic Wikipedia next token prediction didn't budge, but priming cratered almost 2 orders of magnitude down. A 96% median drop in Palm 2. The same trick works, though a little less dramatically, on Gemma and Llama. A quick aside, keeping odd slices like the 70 to 85 percentile band gave partial relief, but Ignore Top K is the cleanest and cheapest knob. One hyperparametric and you're done. For the skeptics wondering about interference, they also trained 2 outlandish snippets from different themes at the same time, 1 per mini batch. Each snippet primed according to its own surprise value, and they didn't stomp on each other. The contamination math, at least at small scale, appears mostly additive. If you're into brain parallels, and honestly, who isn't? There's a neat side note. In mammals, the hippocampus fires harder for novel stimuli. Surprise accelerates memory consolidation. DeepMind's finding that low probability tokens cause bigger, broader updates feels eerily similar, hinting that both artificial and biological learners treat surprise as a universal turn-up-the-plasticity signal. And of course, the paper comes with caveats. The authors admit Outlandish is still tiny by web standards, even though 1,320 isolated training runs were absolute compute hogs. They also haven't nailed down the exact mechanism, especially why Palm 2 couples memorization and priming, while Llama and Gemma don't. And although Ignore Top K works wonders, we don't yet know which layers or neurons pick up the slack after the spikiest gradients vanish. But those gaps don't blunt the practical upshot. If you're shipping a model that will receive continual micro-updates, think real-time news ingestion or personal customization, monitor surprise scores, and maybe schedule a little stepping stone rewriting. And clipping off the top 8% of gradients costs almost nothing. With 1 line of code, you get a model that learns what you want and keeps its mouth shut about irrelevant vermilion skin tones. Before we wrap, let the numbers stick. Outlandish is 1,320 samples, 12 keywords, 4 themes, 11 stylistic categories. Training on one oddball line for just 20 to 40 iterations or 3 spaced hits can hijack outputs if the keyword's prior probability is below 0.001. Priming strength follows that glorious inverse curve rarer words, bigger splash zone. Palm 2 shows memorization and priming marching together. Gemma and Llama dance to their own beat. Insect learning is safer, but not bulletproof. Stepping Stone rewrites cut priming in half to 3/4, and Ignore Top Cap Pruning nearly obliterates it without hurting core performance. Alright, that was a lot, but hopefully it felt more like a story than a slog. If you found that 10 to the -3, or more simply 1 in 1,000, threshold as spooky as I did, maybe hit like or just share it with the next person who says, just fine-tune the model. It'll be fine because, as we've seen, one Vermilion banana can turn an entire knowledge base bright red. Thanks for watching, and I'll catch you in the next one.